Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our book of marine air condition systems. And this is the chapter 5. In this chapter we are going to talk about the accumulator dryer, the expansion valve, and the Y valve or reversing valve. 3 vital components in the refrigeration cycle. Remember, my friends, that at the output of the compressor, this is the compressor. We are going to check the output here. In the output of the compressor, the refrigerant enter liquid. No liquid. At the output of the compressor is vapor. It's vapor, supersaturated, and that vapor supersaturated enter in this accumulator, receiver, accumulator, dryer, and inside of that element start the process of condensation. In other words, enter the gas over there, and in the bottom internally is located in this container a hygroscopic substance. You remember what is the meaning of a hygroscopic substance? This is an example. This is the salt that you use to prepare your food in your home. And normally, in this container, the people put pieces of rice, in order to avoid that the salt absorb too much humidity, too much moisture, because the rice absorb the moisture faster than the salt. Yes, the rice is considered a hygroscopic substance. The hygroscopic substance absorbs humidity. You know, when you buy the pills, internally on those pills, when you buy the pills, different type of pills, internally you found it an element like this. This is an envelope with a hygroscopic substance internally, in order to avoid that the pills absorb humidity and be damaged. This is a hygroscopic substance and is located here to absorb humidity. Exactly the same like the rice that you introduce in the salt. The function of the rice is absorb humidity. Those substances are hygroscopic substances. Yes, inside of the accumulator in this area, in the bottom is located a hygroscopic substance. Right now in the micro video clip we are going to check. I have a cutaway receiver and we are going to check internally that element. Alright, the refrigerant enter vapor and in the bottom start the process of condensation. In other words, in the output is liquid at high pressure, high temperature. This is another dryer. And after that, enter into the expansion valve. And after the expansion valve, the diameter of the pipe is smaller, capillary pipe, and enter in the bottom of the evaporator. Enter in the bottom of the evaporator and start the process of evaporation. We are going to analyze in the next video clip this element, the receiver, and the expansion valve. And we are going to analyze the different type of expansion valves. In the next coming video clip, we are going to analyze the capillary pipe expansion valve. This is the typical expansion valve used in marine application, the capillary pipes, the capillary system. And there are other type of expansion valve used, is the thermal expansion valve that we are going to analyze after that in other small video clip that I prepared for you. Now we are going to check the receiver and the capillary pipes.
Other important element in the refrigeration cycle is the receiver dryer. This is the receiver dryer. This is a section of the dryer. The refrigerant at high pressure and high temperature enter over there. This pipe in the bottom is open, and normally in the bottom of this container there are a hygroscopic substance to absorb moisture, to absorb humidity. After that, the refrigerant continue. The refrigerant enter over there, in the bottom, the hygroscopic substance absorb humidity, absorb moisture. For that reason, the name of that element is receiver dryer, to accumulate moisture over there. And after that, the refrigerant at high pressure continue and enter in the expansion valve. Look at the reduction in diameter. This is the original diameter, this is the output diameter. In this moment, the pressure and the temperature drops dramatically, and after that continue the capillary pipe. This is the expansion valve. For that reason, the receiver dryer is located in between the output of the compressor and the expansion valve. It's located in between the output of the compressor and the expansion valve. And the function is absorb humidity, absorb moisture, and start with the process of condensation, because just at the output of the coil is vapor, but after that, when the refrigerant enter in the receiver, in the output is liquid, and continue liquid at high pressure, and high temperature is liquid. In the other side is liquid at low pressure and low temperature, and after the capillary pipe start to evaporate in the bottom of the evaporator, continue the evaporation and goes out completely evaporated and enter again in the system. This is the function of the receiver dryer or accumulator.
Yes, as you can see, this is the function of the receiver, and this is the function of the capillary pipe. The capillary pipe, of course, reduces the pressure and the temperature dramatically. We have another type of expansion valve, is the thermal expansion valve, like this one. This one is a thermal expansion valve, and the function is exactly the same. Receive the refrigerant, high pressure and high temperature in one side, and in the output of that expansion valve, of that element, of that device, the temperature and the pressure of the refrigerant reduce dramatically, and in the other side continue liquid, but is at low pressure and low temperature, and start the process of evaporation in the evaporator. This is the thermal expansion valve. But let me refresh something about the what happened before the expansion valve and what happened after the expansion valve. Remember that before the expansion valve, doesn't matter if it's capillary pipe or if it's a thermal expansion valve, the pressure decreased from 220 psi into 70 psi. This is the reduction in pressure. It's coming from 225 into 70 psi. The pressure is reduced dramatically, no? And the temperature is going from 110 into 40 degrees. The temperature goes down from 110 degrees before the expansion valve, and 40 degrees after the expansion valve. The refrigerant. 40 degrees Fahrenheit is practically the frozen point in degrees Fahrenheit. You remember what is the frozen point of water in degrees Fahrenheit? It's 32 degrees Fahrenheit, no? 32 degrees is ice. Oh, the refrigerant passed from 110 into 40. It's practically ice. Ice for you and me. For the refrigerant, 40 degrees Fahrenheit is high temperature, because you remember what is the boiling point of the refrigerant is around minus 20 degrees Fahrenheit. Minus 20 degrees Fahrenheit. At that point, the refrigerant starts to boil. Of course, in 40 is ice for you and me, but for the refrigerant is high temperature. For that reason, the refrigerant immediately after the expansion valve starts to evaporate, because it's too much temperature. Additionally, when the refrigerant passes through the coil of the evaporator, the ambient air passes through those coils, and the refrigerant evaporates quickly. In the output of the evaporator, the refrigerant is too hot for the refrigerant. For us, continue low temperature. You touch the pipes in the output of the evaporator, and those pipes are too cold. But for the refrigerant is boiling. It's completely evaporated, the refrigerant. And that refrigerant, fully evaporated, enter in the suction side of the compressor, and the cycle continue again. That's important that you keep in mind this slide. This slide is very important. Before the expansion valve, the pressure is around 220, 225, 250, depending on the refrigerant, psi. And after that, the pressure is around 70 psi, 60, 70 psi. It's a huge reduction in pressure, but the reduction is also in temperature. Yes, at the input of the expansion valve, the temperature is around 110, 115 degrees Fahrenheit, high temperature. And in the output is 40 degrees Fahrenheit. It's practically ice for you and me. But for the refrigerant, it's too hot. Because the refrigerant, the melting point is at minus 20 degrees Fahrenheit. Of course, at 40 degrees Fahrenheit, it's boiling. For that reason, immediately the refrigerant pass through the expansion valve, start the process of evaporation. Yes, at the input of the refrigerant in the evaporator in the bottom, the refrigerant start to boil and become is liquid and become vapor immediately. And vapor, and in the output of the evaporator of that coil, this is the inside coil, is completely vapor and enter at the suction side or input side of the compressor. Remember, the compressor have the input side. The other name of the compressor, the suction side, is a input side, suction side, or low pressure side. In the output is discharge side, supply side, or high pressure side. All right? Okay, that's clear. That's the movement of the fluid. And remember that we have two coils. One coil externally and other coil internally. In your home, you have one coil internally in the closet, in the cabinet of your home. And you have another coil outside. In the backyard of your home, you have another coil with a fan over there. That's clear? You have external coil and internal coil. This is important because in the next part of this episode, I am going to explain the reversing cycle. And we are going to play with that, with those coils, the inside coil and the outside coil. And we are going to change the cycle of refrigeration cooling mode into heating mode, depending how the refrigerant is moving, through this coil or through the other coil. Right now I am going to explain that process. Keep in mind this. We have the compressor. The compressor is the center. Remember that slide. The compressor is the center of the system. And we have two coils. We have one external coil, and we have an indoor coil, outside and inside. Yeah. And this is the compressor, and we have the expansion valve here. In this particular case, this is a thermal expansion valve. Okay, this expansion valve works with a different principle. It's not different. It's pretty similar, but the concept is different. That thermal expansion valve. Remember that we have basically two types of expansion devices. We have the thermostatic expansion valve or thermal expansion valve, and the capillary pipes. The capillary pipes is the example that I explained before in the micro video. The next one, this one here, is a thermal expansion valve and work with a simple principle. Work with a simple principle. Let me explain quickly. Look at this. This is the thermal expansion valve, and remember that it's located here, no? It's located in this point. It's located here. The thermal expansion valve receives high pressure refrigerant at high temperature and high pressure liquid. And in the output is liquid at low pressure and low temperature. Remember, the pressure in the output is 70 psi and the temperature is 40 degrees Fahrenheit. Low pressure and low temperature. In the input is 225 psi and 110 degrees Fahrenheit. All right. This is that thermal expansion valve. That thermal expansion valve internally have a diaphragm, and the diaphragm is deformated, extend and return depending of the pressure inside of the diaphragm, and that pressure is coming from this bulb, and this bulb is together with the return pipe from the evaporator. Remember that the evaporator have a small capillary pipe entering in the bottom, an output pipe with big diameter in the output because the refrigerant is completely evaporated. That pipe in the output, this one, in the output is a bigger pipe. That's the pipe that enter in the suction side of the compressor. Okay, in that pipe we are going to put together the bulb. That bulb have a small capillary pipe connected with the diaphragm internally of this thermal expansion valve. When the diaphragm is deformated, the valve open and the fluid pass from here to here, and the reduction in pressure and temperature is produced because the diameter in the output is too small in comparison with the diameter in the input. This is the function of the thermal expansion valve. But the secret is this bulb. This bulb internally have a substance that expand and retract easily with a small change in temperature, like mercury. Mercury is a good example because mercury with a small change in temperature expand and retract. For that reason, mercury is used in the thermostat to indicate where is located the temperature in this moment. Yes, internally of that bulb is a substance that contain mercury and expand and retract. Is exactly like this, and the operation of this device is this. Look at this. The refrigerant at high pressure and high temperature enter over there, and here is located the diaphragm. The diaphragm is located here. And this is the small capillary pipe, connected with the bulb. And this is the discharge side. Suppose that this is the compressor. This is the compressor, and this is the suction side, and this is the high pressure side. Okay, in other words, in this output you have a gas, vapor, high pressure, high temperature, and in the input here we have a vapor at low pressure and low pressure and high temperature for the refrigerant. Okay, this is the suction side, and this is the bulb, and the bulb is touching the pipe. Normally the bulb is close to the pipe, and with the electric tape is together on the pipe in order to sense the temperature of the input pipe of the compressor, in order to sense the temperature of the input or suction side of the compressor. You know, with that temperature, the mercury inside of the bulb expand and retract, and this diaphragm expand and retract. When this diaphragm expand, open the valve, and the refrigerant pass from this point and enter here at low pressure and low temperature because the diameter over there is reduced dramatically in comparison with this diameter. This is the expansion valve, and work with a signal coming from the bulb. It's exactly like this.
This is the refrigerant with high pressure and high temperature, and this is the thermal expansion valve. The thermal expansion valve operates with the diaphragm internally open and closed depending on the signal. The signal is coming from this small capillary pipe connected to this bulb. Internally in this bulb, they have a substance similar to mercury. According with the temperature of this, the mercury expand or retract. Depending how much expand or retract, the diaphragm move back or forward and open and close and allow that the refrigerant pass through the venturi. Immediately the refrigerant pass through the venturi, the pressure and the temperature drops dramatically in this pipe, and in this moment is practically frozen, and the refrigerant frozen internally. The pipe is frozen pipe, and the refrigerant continue here, evaporated right now, and enter once again in the compressor to start the cycle again. The compressor compress the refrigerant and send the refrigerant with high pressure. The refrigerant pass through the accumulator. The refrigerant right now is liquid with high pressure and high temperature and pass through the expansion valve. The expansion valve open and close depending on the signal. The signal is coming from this valve, and this valve is touching this pipe with refrigerant internally. Okay, the refrigerant internally is coming from this serpentine. Evaporate, and the refrigerant right now is evaporated, and the refrigerant enter again in the compressor. This is the cycle we are going to repeat. This is the compressor, high pressure in this point, high pressure and high temperature, vapor supersaturated. The vapor supersaturated goes down, enter into the accumulator, and in the accumulator right now is liquid, high pressure and high temperature. This is the thermal expansion valve. The thermal expansion valve receives the signal from this capillary pipe, and this capillary pipe is connected with a bulb, and the bulb is touching this pipe. This pipe is the return, the output of the evaporator. When the expansion valve open, in the bottom goes the refrigerant right now. The pressure and the temperature reduced dramatically and froze this pipe. This pipe is protected with insulation because it's frozen. And that frozen pipe enter in the bottom and pass here and start to evaporate the refrigerant. And right now, here in this point, the refrigerant is evaporated, but it's too cold, of course, it's evaporated, and continue evaporated, vapor, and enter in the compressor, and the cycle start again and again.
Yes, it's clear. This is the operation of the thermal expansion valve. It's pretty simple. Don't forget, in terms of expansion valves, we have a capillary pipes expansion valves, or we have a thermal expansion valve like this one that I explained right now, and I explained in the video clip. There are other type of thermal expansion valve adjustables for industrial application, but for marine application, those are the expansion valves used that we are going to use commonly in this course. And now we are going to analyze the reversing cycle. The reversing cycle is possible because in the system we are going to introduce the four-way valve or reverse valve. This is the valve. This is the reversing valve or four-way valve. This is a special valve that sends the refrigerant in one direction, send the refrigerant into the external coil, or send the refrigerant into the internal coil. Depending where is the refrigerant coming out from the compressor, you have a cooling mode or you have a heating mode. This is possible because this valve, the four-way valve or reversing valve. The reversing valve is a type of valve that change the direction of the flow of the refrigerant. This is the function. Normally, in the middle of the valve is entering the vapor, high pressure, high temperature coming from the output of the compressor. And depending where is located, a special piece of metal located inside is a metal like this, and this is moved by this solenoid. Depending where is located that piece of metal, the fluid goes in this direction into the external coil, or depending where is located the piece of metal internally, the refrigerant is going here into the internal coil. Oh, if the refrigerant, high pressure, high temperature, vapor, entering into the internal coil, the coil that you have inside of your home, you have the heating mode. If the refrigerant at high pressure, high temperature is going to the external coil, you have the cooling mode. Simple. Exactly. That's the function of that valve. Send the refrigerant through the internal coil or through the external coil. And that's it. In that case, you have cooling mode or heating mode. Yes, this is possible because of this valve and this piece of metal in the middle, and it's possible because this solenoid. The solenoid is activated with a signal in between 24 volts AC and 30 volts AC. That signal is coming from the computer. You remember the main board of the air conditioning system located in the control box. Normally the control box is close to the condenser. Alright? From the computer is coming the signal to activate the solenoid of the reverse valve is set in between 24 volts AC and 30 volts AC, AC power, right? This is an AC signal, this is an AC solenoid. You remember we studied solenoid in previous courses, in previous classes. It's a solenoid, but in this particular case, the coil is powered with AC power. All right, and now I am going to check it quickly. Exactly, this is the example that I prepared for you. Suppose that you have this situation. This is the compressor. This is the compressor, and this is the output of the compressor. This is the vapor, high pressure, high temperature, and enter in the Y valve. In this moment, the piece of metal is located here. That's the piece of metal, and the refrigerant is allowed to pass over there and enter into the outdoor coil, external coil, outdoor. Okay, in that case, the refrigerant enter over there vapor and immediately become liquid. In this case, this is working like a condenser. After that, the refrigerant is liquid and enter in the expansion valve. Remember that the expansion valve have the sensor with a capillary pipe, and the bulb is located here. Alright, the expansion valve open according with the temperature of the refrigerant coming out from the evaporator. Okay, the thermal expansion open, and the refrigerant enter here liquid and start to evaporate. And because the piece of metal is located in this position, the refrigerant enter over there, continue over there, and enter in the low pressure side. In this particular case, in this particular situation, in that picture, the system is working in a cooling mode because the external coil outside is working like a condenser and the internal coil is working like an evaporator because this piece of metal is located in this position. If the piece of metal is located in the other position, the fluid goes in the other side. Right now, I am going to analyze that situation in the video clip that I prepared for you in order to analyze this particular situation. We are going to analyze the cooling mode. This is the cooling mode. This is the output of the compressor. The output of the compressor enter in the middle of the Y valve, and the refrigerant at high pressure, high temperature goes over there and enter in the outdoor coil. In this particular case, is the condenser. It's working like a condenser. After that, pass through the expansion valve and enter into the evaporator and return here because that piece of metal is located in this position and enter into the return. This is the cooling mode. And what about the heating mode? In the heating mode, the refrigerant is going directly into the indoor coil. This is the indoor coil. In other words, the evaporator that you have in your home inside, in that moment, is working like a condenser. And when the fan passes the ambient air through the coil, in the other side is hot air. That's the heating mode. And the refrigerant goes into the expansion valve and enter into the evaporator, but right now the evaporator is located outside. And the refrigerant return here, and enter over there. This is the heating mode. Depending where is entering the refrigerant, in the indoor coil or in the outdoor coil, you have heating mode or cooling mode. That's the situation that we are going to analyze in this video clip.
In the typical refrigeration cycle, we have 5 components, 5 important components. The most important, the heart of the system, is the compressor. The compressor compresses the refrigerant, and the refrigerant, depending on the pressure, absorb heat or release heat. That's the number one. That's the compressor. We have 2 coils. We have one outdoor coil or outside coil that in the normal cooling mode is working like a condenser. One coil outside. And other coil inside that in the normal cooling mode is working like evaporator. We have 2 coils, outdoor coil, indoor coil. We have the compressor, and other vital element that we explained before is the expansion valve. The expansion valve receives the refrigerant from the receiver, receive the refrigerant liquid at high pressure and high temperature, internally decrease the diameter of the pipe, the input pipe and the output pipe, the diameter decrease, and of course the pressure decrease dramatically and the temperature. And in the other side you have liquid at low pressure and low temperature. That liquid enter in the indoor coil and start to evaporate. In the output of the indoor coil you have a vapor, and that vapor enter at a low pressure, high temperature into the compressor, and the cycle continue again and again and again. In other words, the secret is, of course, the refrigerant. If the refrigerant is entering into the outside coil, or if the refrigerant is entering into the inside coil. In normal conditions, in an air conditioning equipment, in the cooling mode, the refrigerant going out to the compressor at high pressure and high temperature enter into the outside coil, and in that coil is produced the condensation of the refrigerant. For that reason the name of that coil is condenser, and the cycle continue in the same way that I explained before. But what happens if the refrigerant going out to the compressor like this is not entering into the outdoor coil? That refrigerant is entering into the indoor coil. The refrigerant enter into the indoor coil. Right now, in the coil that I have inside of my home, the refrigerant enter at high pressure and high temperature. What happened in the other side of the fan? I receive hot air. This is the heating mode. In the output of the indoor coil, right now, the refrigerant pass from vapor at the input, and now is condensated, and we have a liquid at high pressure and high temperature. That liquid enter into the expansion valve. In the other side, I have liquid at low pressure and low temperature, and that refrigerant enter into the outside coil. In this moment, the outside coil is working like evaporator. Enter in the bottom of that coil, start to evaporate, and in the output goes out, pass through the white valve to the U, and enter in the suction side of the compressor. This is the heating mode, because the indoor coil is working is working like a condenser. In the other mode, the indoor coil is working like evaporator. Yes, because in the discharge of the compressor, the refrigerant goes out, pass to the Y valve, because the position of the metal in the Y valve is in this side. The refrigerant at high pressure and high temperature, gas enter into the outside coil and start the condensation. Is condensed, pass to the expansion valve. In the other side of the expansion valve, enter again into the indoor coil. Now the indoor coil is working like an evaporator. Receive liquid in the bottom. The liquid start to evaporate, and in the output is a vapor, and that vapor enter in the suction side of the compressor. Yes, depending of the flow of the refrigerant from the output of the compressor, we have a cooling mode or heating mode. That situation occurs because the Y valve, this is the Y valve. The input of the refrigerant coming from the output of the compressor at high pressure, high temperature vapor enter here. And depending of the position of this piece of metal, here or here, the refrigerant goes over there through the outside, or goes here through the inside, and is produced the cooling mode or the heating mode. This is possible because this element is moving here or here with a solenoid, and this is the solenoid, and the solenoid receives the signal in between 28 30 volts AC. That signal is coming from the computer of the air conditioning system. This is an AC signal in between 28 and 30 volts AC, and that signal moves that metallic element inside of the Y valve. This is the input of the refrigerant coming from the output of the compressor, and the refrigerant goes in this direction, or the refrigerant goes into the other direction, and depending if the refrigerant enter into the outside coil, is produced cooling mode. If the refrigerant is entering into the inside coil, is produced cooling mode. Is produced heating mode. And it's basically because this valve, this solenoid valve, changed the position of this metallic element and changed the flow of refrigerant outside or inside, and the system produce heating or cooling. This is the Y valve, and this is the function of the Y valve or reversing valve, is reverse the cycle.